What's up everyone, this is Ryan here. So in the previous video we looked at building just a very basic retrofit implementation, and what we're going to do in this video is for starters look at a couple ways we can improve that. So we're going to be looking at using OKHttp's Interceptor interface, and that's going to help us with error handling. Then we're going to look at adding a repository in to sort of abstract our presenter from our model. And then what we're going to do is we're going to look at using RxJava to kind of wire everything together, and it's also going to help us out with our error handling. So that's basically it for this video. If you like this kind of content, please do me a favor, hit the like button below, consider subscribing, and let's get started. So one of the first things I'd recommend you add to your REST adapter is some form of error handling. In this particular case, we're using Retrofit and OKHttp, and a super easy way to do that is with OKHttp's Interceptor classes. So we're going to have a look at creating one of those. Essentially how this thing is going to work is I want you to basically think, so we've got our application code kind of here, and then we can have an application level interceptor, and then we can have sort of like our retrofit OKHttp implementation, and then a network level interceptor. So in this particular case, we're concerned about having that application level interceptor. And what that's going to allow us to do is as a response from the server comes in through our implementation, we can kind of stop it at a certain point and check its status. Now, there's a lot of different things you can do with these interceptors beyond error handling, but in this case, that's all we're really concerned about for now. So let's get started with it. So within the package here, starting point package, go ahead and right click on it, go to new package. We're going to call this package error. I'm just going to call it that because I want to keep my error handling stuff in one place, but you can put it elsewhere if you like. And what we're going to do is right click on there, go to new Java class, and let me just pull up my notes here. Oh yeah. New Java class, and this one's going to be called error interceptor. There we go. And the interface is going to be Interceptor. That's the OKHttp interceptor. And that's going to look like that. So we're going to click on the red text, go to Alt Enter, implement methods, hit enter twice. And there we are. We have our intercept method. So what this is essentially going to look like is this chain object here gives us access to a couple of different things. Like we can get a response object, which is in this particular case what we're looking for. We can get request objects, and we can get a hook to the connection. It's all kind of different stuff, and you should really check out articles online about the interceptor because there's a lot of cool stuff you can do with it. In this particular case, we just want to get a hold of responses. So I'm going to say response equals chain.proceed chain.request, just like so. And then, so that's basically going to get a hold of the response momentarily before it goes back into our application, as I mentioned before. What we're going to do next is just go if, I can't believe I almost forgot what that's called, exclamation mark, so the Boolean not. So if response isn't successful, if response.is successful there. So what we're saying here is if the response isn't successful, we want to throw some kind of exception. So in this particular case, what we're going to do is I'm going to type throw new GitHub exception, which is of course a class we haven't created yet. And within that, we're going to say response.code and then response.message. So for code, that's of course going to be like the HTTP error code. So we're going to want that. And if there's some kind of a useful message, and with GitHub being our API, there probably is, we're just going to want to basically grab this information. Again, we're going to only handle very basic stuff, but this is kind of a good start here. So the next thing I'm going to do is we've kind of got this set up here. Just to finish this class off here, we're going to type return response there. So that's all we're going to handle here. Essentially, we're just going to grab a hold of this response, check if it was successful. If not, we're going to throw an error. That's fairly unambiguous. I'm going to hit Alt Enter again. and we're going to create class GitHub exception. Destination package is error, and let's go ahead and do that. So what this particular class is going to look like, int code and message is totally fine. Oh yeah, I love it when it helps me with the auto complete there. Okay, so public GitHub exception, and so what we're going to do is we're going to add two variables. That's going to be private int response code, then we're also going to add private string message, just like so. And we're going to add some, let's just add a getter in this case, so alt insert rather, getter, and we can just do the those two there, get message, get response code. And then yeah, all we're going to do here is just say this dot response code equals code, and this dot message equals message. So all we're basically doing here is I just want to have some class that records essentially the issue that happened with the OKHttp REST adapter kind of implementation. And what we're going to be able to do is sort of look at the particular code, and we can sort of, if we wanted to, create specialized error messages. At least that would be sort of my intention. So we're basically going to leave that there for now. This is basically a way in which we can, of course, arrest a response, and if it has an issue, just kind of check on that. And yeah, one quick change here. We're just going to change this to IO exception, and that should fix up what's going on here. All set. All right, so the next thing we're going to be talking about is presenters and repository patterns. So if software architecture has always been kind of a vague and mysterious thing to you, you're probably going to like this. One of the fundamental principles of good object-oriented software design is that high-level modules should depend upon abstractions. I go into great details about this in my video on dependency inversion principles, so if you're curious about what I mean by that, if you want me to unpack all that, then go check out that video, because I give you quite a detailed explanation of what the repository pattern is and how it kind of relates to the dependency inversion principle. In technical terms, we want our presenter, which I would argue is a high-level module, depending on your definition of module, to talk to its dependencies through an abstraction, which in Java is probably going to be either an interface or an abstract class. So in more practical terms, we want our presenter to know very little about how our back-end manages and fetches the data, so that we can change the backend very easily without having to go back and change the presenter. So that's basically why we would want to employ this pattern, if you're curious. And I'm quite fond of it because it gives you an sort of an immediate idea of how even just the way we have our classes talk to each other in terms of architecture can actually solve problems before they become problems. So that's basically it. Let's jump into the code and write our presenter and a repository. So before we get into writing the presenter and the repository pattern, what I wanted to talk about briefly is just the concept of having a separate model for the back end of your application and for the front end. Now, unfortunately, because of the fact that people decided to name model view model as such, which is an architectural style which wasn't originally called that, there might be a little bit of confusion here. So when I say view model, I'm not talking about what people generally think of as the model view model architecture, which is actually a pretty poor term, if I might say so myself, but whatever, I'm not going to go on that rambling. What I will say is that when I say view model, I mean a data model class which is sort of purpose-built for the view, and a data model class which is purpose-built for the backend. And what you'll generally find is that you'll want to translate the data as it comes in from, say, a database or a REST adapter. You'll want to translate it from this data model to more of a view model, if that kind of makes sense. I want to get away from the terminology because everyone uses different terminology and it just confuses the hell out of people, but let's just have a quick look. So as we saw earlier, this was the class which kind of represents the data as we pass it or as we receive it from the REST adapter or the REST service. So basically, this class here is kind of ugly and contains sort of frameworks for our sort of backend and things of that nature. And longer story shorter, generally speaking, you'll want this sort of data model, or the data that you pass in from your REST adapter or your database or whatever, to be translated into something which is easy for the view to consume and doesn't contain implementation details about the data layer, like for example that we're using this particular Moshi annotation. Now, instead of handwriting all of this code, all I've done is I've gone to the finished app module here, and I've copied and pasted in this view model package. We're not going to handwrite them, but I'll just talk about them briefly. Essentially what this class is, and I was inspired by this particular talk by Jake Wharton here. Just Google, you can check out the repository for this link, but it's also called Managing Application Lifecycle, or Managing Application State Using RxJava, I believe, or something like that. Whatever, just go check out this link here. And also a blog by Dan Liu. And so essentially what we're looking at here is we want one sort of object which is capable of representing multiple different states of the view. So this is one way to approach this. If you wanted a simpler solution, you kind of could just pass in a list of data to the presenter and have it send that to the view. In this case, we're going to do something a little bit different, but it's a little bit beside the purpose of this tutorial, but this is just kind of something I wanted to give a try. So we're not going to go into much detail, but what this list view model class does is it's either going to be able to represent a simple error state, so not like a fatal error, more on that later when we actually write the RxJava stuff. It's going to be capable of representing a loading state, and it's also going to be capable of representing a state where we successfully retrieve the data from our REST adapter. And what that's going to look like is it's going to be given a list of these repository list item objects. So a repository list item is really just a translation of this class here, except it's just easier to go from here to the data model, for example. So, and then eventually what's going to happen is our recycler view implementation will receive these model objects and it will map them to the user interface. Anyways, longer story shorter, all I've done here is I've got this class, this list view model class, and it's capable of being created statically through three different kind of convenience methods. So the first one is list view model loading, and so this is just going to be like a default state that we load this view model in. And then we have a success state and then an error state. Wait until we actually get to writing this, then all this will make sense. But I had to talk about this first, and I'm going to get you to copy and paste this over into the starting point project, because we need this stuff in order to write the presenter and the repository. So anyways, longer story shorter, I'm just going to have you just make sure you copy and paste that package over, and then we'll get started writing the repository now. Alright, so we only have a couple classes left to write, so that's going to be our interface, our repository implementation, and our presenter class. Now, I'm going to be honest here, it's actually taken me a few days to figure out how to demonstrate the following approach to wiring up our backend and our front end with RxJava, which is ultimately what the rest of this video is about. The reason for this difficulty is that I'm in a position where I really want to show everyone how our RxJava implementation is going to easily help us handle concurrency, improve our error handling, help us do things like display a loading screen when our activity starts, and make UI updates as easy as just like passing in a view model. It's just really going to solve a whole bunch of problems for us. The problem with that plan, as I realized pretty quickly, is that RxJava 2 is not particularly easy to explain or learn, let alone in a few minutes. So here's what we're going to do. We're going to start by going line by line through the RxJava 2 implementation, and instead of overloading you with a whole bunch of jargon and stuff like that, we're really just going to focus line by line. What does each line do? What little piece are we adding to our reactive stream with each little operator and things of that nature. Again, getting away from the terminology. So once we've gone line by line, and I'm going to try and explain it in simple terms so that you can roughly grasp what's going on, then I'm going to give you some terminology and definitions and probably a visual metaphor of what's going on, with the idea that maybe you can then kind of go back and be like, okay, I kind of see what's going on here a little bit better. So this is a big experiment. In my experience, I've never really seen a video which can introduce you to RxJava in a concise and effective way that, you know, really takes you pretty far from the beginning beyond just creating basically what is an async task with RxJava. But longer story shorter, try and stick with me. If this stuff seems very confusing at first, that's totally natural. Just carry on. Everyone goes through it. And hopefully by the end of this video, you will start to see not just how RxJava 2 works if you're a beginner, but you'll start to see all of the benefits that it affords us in an application like this. So without further ado, let's get started. So before we get into writing the okay, I'm just kidding. Let's just write the damn code. So what we're going to do is on the data package of the starting point project, or module rather, right click on it, go to new Java class, and we're going to call this class repository data source interface. I always like to give things a long and descriptive name over a small, efficient, and obscure name, especially because a lot of people end up looking at my code, but you can name it whatever the hell you like. In this case, this is actually going to be an interface, so just make sure that that's selected. And there we are. So, this is kind of an involved class to write. This is the sort of the start of our RxJava 2 stuff. So the first thing we're going to do is we're just going to type Flowable list view model get user repositories, and that's going to accept a string user. If you're not super familiar with interfaces, I do have a big long video on Java interfaces, so go ahead and check that out. So we've written our first class. I actually lied. This is all we need to write for our interface. And so essentially what's going to happen is this is the class or interface rather, that our presenter will be depending upon. And that way it's not going to actually know what's behind the interface. It's just going to know that whatever's behind it must return a flowable of type list view model when this method is called, and it should expect a string user. So again, as I said before, we're not going to get into the terminology just yet, but what are we actually saying here? In simpler terms, return a resource which is capable of emitting a list view model. So it's important to note that we're not actually, this is what we ultimately want to get out of this flowable thing, whatever it is. Think of it like a wrapper for now. And we're going to be returning a flowable which is just capable of emitting a list view model. So you could almost think of it like we want to return maybe a pipeline which is capable of producing things out of it, but we're not necessarily immediately returning an actual list view model. We'll kind of see how we can do that later. So that's basically it for the interface, and let's go ahead and get started writing the implementation. Okay, so the next thing we're going to do is actually write our presenter, because we can do that now that we have our interface set up. So I'm going to right click on the repo list package 3 times apparently, and we're going to type list presenter, and that's all we need to do there. And here we have our presenter class. So as I said, we're going to kind of go through this line by line. It is going to take a little bit of time, but let's just get started here. So first and foremost, we need our view and data source as member variables. These are the things that our presenter will actually talk to, and it should talk to them through abstractions in my humble opinion. So we're going to have view interface view. So this would generally, let me zoom in a little bit. This would generally be an activity or fragment, or maybe a compound view, but let's not really get lost in minutia. And then we're also going to need an instance of our data source interface. So we're going to say repository data source interface, data source. So essentially what this is it's the abstraction of our data source. So why do we bother doing this? In simpler terms, this is a big topic, but longer story shorter, the reason why we want to know our data source, we want our presenter to know the data source through an interface, which is kind of a way of abstracting it, is because that way we can change the implementation of our data source, the thing that's behind the interface, without needing to change the presenter afterwards. And we could do other things. We could add a local and a remote data source. So I just really want you to take note of this. This may not seem like much, but this is like one of the most powerful concepts in like object-oriented software design. Just wink, wink, nudge, nudge. So yeah, really good to talk to data sources through abstractions. And let's just kind of move on. So we're also going to need this composite disposable object. There's too much jargon for me to explain this right away, so we're just going to say, just add that in and let's kind of gloss over it for now. And the other thing we need is we're going to need a base scheduler provider, and we're going to call that scheduler. I can't explain this one in simple terms. Let me just like briefly say this helps us manage our reactive streams for now. I'm not even going to be more descriptive. This thing is a little more easy to understand though. So essentially what this thing does is it helps us provide our Rx implementation with schedulers. Now, really simply put, I'm not going to spend a lot of time on this, but if you check out the finished application and also the starting point, I want you to notice there's two product flavors. There's mock and prod. And within the mock product flavor, this is the class which we're going to actually be providing behind the interface. And in the mock version of this scheduler provider, it returns schedulers.trampoline. And in the other one, it returns schedulers.io computation or main thread. All I want you to think about here is that these classes allow us to control which thread our code will be operating on. We'll see how that works later on, but when you're running unit tests, here's a quick tip. You want to use schedulers.trampoline. It used to be called schedulers.immediate in RxJava 1, I think, but yeah, this is just purely so that I can run unit tests in case you're wondering. Anyways, let's kind of move on here. So back to our presenter. So we're going to go ahead and create a constructor. So hit Alt Insert Constructor, select everything, enter. It's going to do that. So we're just going to kind of clean. Oh no, that's not what I wanted to do. There we go. Just kind of clean that up a little bit. Perfect. And then what we're also going to do is slap an inject annotation on here. Now, because I've pre-configured all the Dagger 2 stuff, then you can just go ahead and slap that annotation on and don't worry about it. Just understand that this stuff is going to be created when it needs to be. Like, really not going to get into Dagger 2 here, but go ahead and add that in there. All right. So for, let's see here. So we're actually not going to pass in the disposable object, so we can go ahead and get rid of that one. Just like so. Oops. And then for disposables, we're just going to say new composite disposable, just like that. So that's all we need to do for the constructor. So we're going to slap in two methods here to start and stop our kind of presenter. And normally a pretty typical pattern is you would sort of link these up to say the on stop or on pause or on destroy, whatever kind of lifecycle methods for your fragment or your activity. In this case, we're not going to harp on that too much, but we're just going to say public void start string user. And within that, we're going to say, we're actually going to create a helper method. So this is one thing I quite like to do. So we're going to say get list from data source, and I hear my old friend the garbage truck is outside, so we'll see how loud that is. Anyways, we're going to say get list from data source, pass the user in. So the reason why I've done this here is literally so that if someone's looking at this code, they understand when this presenter starts, we want to get the list from the data source, get a list of data, essentially. So I'm going to go Alt Enter, create method. That's going to create that down below. But before we get to that, we're just going to create a stop method. Public void stop. And what we're going to do there is we're going to just say disposables.clear. Don't worry about this too much, just understand helps us stop our background operations when they should be stopped. Really in simple terms there. This is the method, the last method we need to actually write in this whole class, where all of the magic is going to happen. So this is where we really need to kind of go step by step here. So first things first. Whatever happens with our sort of reactive stream here, we're going to want to add it to our disposable implementation here. So I'm going to wrap everything that's about to follow in a disposables.add method right here. So all I want you to understand is that this thing is almost like a list of flowables, and at the end we can kind of, when we want to, dispose of like an arbitrary number of flowables. Blah, blah, blah. Let's not really worry about that. Again, if this doesn't make sense, just don't even worry about it. Let's get to the important stuff. Okay, so first things first. The first thing we need to do is we're going to say to our data source, we're going to say DataSource.get user repositories, and we're going to pass in our string. So this is of course referring, or ultimately going to get passed into our REST adapter. But what we're saying here is from this data source, we're basically going to say return data from the data source wrapped in a flowable. So this is what essentially the first line of code does. That's all I want you to think about. We're returning a flowable which is capable of producing our view model objects as per the interface we wrote earlier. So line number 2. For line number 2, we're going to say .observe on scheduler.getUIScheduler. So that was that scheduler class I talked about just a moment earlier. Why is there an extra set of brackets there? All right, so observe on scheduler.getUIScheduler. What we're saying here is return this data on the UI thread. So just like with an async task, do in background operates on a background thread, on post execute returns that result on the UI thread. That's essentially what we're doing here. We're saying whatever happens, whether the code executes on a background thread, I want it to be returned, observed or returned on this UI scheduler. So again, let's just kind of keep barreling through here. So number 3, we're going to say start with. So this is kind of our first RxJava operator. And what we're going to say here is we're going to say list view model dot loading. So what does this code mean? We're saying before this thing even kind of returns a value, the moment we kind of set up this whole data stream, I want to produce a list view model dot loading. So that's what we're going to create as like basically before anything else happens, and we'll see where this is going to pop out in the pipeline afterwards. The next thing we're going to add is another operator, on error return. So what we're saying here, I'll just add in the, sorry, I forgot to write out what this does. So start our stream with a loading screen in simpler terms. And this next one here, we're going to say, oh, oops, just gonna, sorry, I know this is really ugly and I'm trying to format it decently well here. So 4. So in this one, we're basically going to say if an error is thrown, return a list view model dot error instance. So essentially what we're doing is if any part of our program or anything that sort of fits within this stream throws an error, which will include our error interceptor. This is a really key point. If our error interceptor throws an error, it's going to pop up here. So we're basically saying this is where I want to handle those kinds of errors. So anyways, let's just kind of carry on here. So what we're going to do is within here we're going to type, and this is, you know, some good old RxJava magic, new function throwable list view model. And so what we're going to do is we're going to return list view model dot error with throwable dot get message. So I realize we have a lot of stuff going on here. So again, essentially all I want you to think about here is we're saying on an error, if an error is thrown, do the thing below. And in this case, we get access to the throwable, which say our interceptor might throw. And then we sort of have this method here. What we're saying is this is what we want to produce, and this is what is going to come into this method. So as you can see, throwable shows up here, and our return type is list view model. So we're saying when we get an error, get the throwable, create a view model, and return it. The next thing we're going to do is see where all of this stuff actually pops up in the stream, and that's going to be with number 5 here, which is going to be .subscribe with. Within subscribe with, we're going to say new disposable subscriber. Yes, subscribe with new disposable. I'm not sure why it's there. We go. I was waiting for that autocomplete. And for the type, we're just going to say list view model. I'm going to hit Alt Enter, implement methods, and then all of a sudden we're going to see all of our good old standard RxJava callbacks. So let's just kind of go through these bit by bit. So what we're saying here is the resulting, let's just say the resulting flowable should be subscribed to with this new subscriber. I realize I wasn't going to talk about much jargon, but it's just useful for me to tell you this right here. What we're saying is the result of this thing here, this whole big chain, whatever happens, whether it, you know, it's going to start with a list view model, whether it throws an error, whether it gets like a successful return, whether it successfully returns the data from our data source, all of that is going to be handled here. This is our big callback for all that stuff that's going on. So within this callback, most importantly, we want to worry about on next. So within on next, we're going to add a couple different things here. So we know ultimately that we're going to get this list view model object here, and I'm actually just going to change that to UI model just to like kind of hopefully clear things up a little bit. This is literally a model of different user interface states. So when we get a UI model, handle it here. So there's kind of 3 different things that can happen. So we're going to say if UI model dot has error, which means if this kind of view model was created essentially. So if we have an error state, then we're going to say view.show error message, UI model.get error message. Let me just kind of recenter this a little bit here. And then we're also going to say view.start main activity. And this is just going to take us back to the sort of the submit main activity. Then we're going to say else if UI.model, UI model dot is loading. So if we've started the stream, we haven't connected to the REST adapter quite yet, but whatever, we're just going to start it and we want the view to show a loading screen. We say if UI model dot is loading, view dot show loading indicator. And the last thing we have is if we successfully return the data, we're going to say view.setupAdapter and view, and then we're going to say UIModel.getRepoList. So essentially we're saying, hey, UIModel, get us the list of data. And it looks like we have a little bit of an error there, but we can go ahead and fix that in a moment. It looks like the adapter isn't set up quite properly. Repository list item. That's okay, we'll fix that in a moment. Let's just carry on. Now, we're not really going to actually call this onError method here. So this is where you would handle application, I'm just going to say application terminal errors. So this is where you want errors which are like majorly bad to sort of pop up. And so when you would want to like just totally wreck everything. Whereas what we're ultimately trying to do here is say, okay, when there's an error like the user types in the wrong username for GitHub, we don't want to treat that like a fatal issue. We want to treat that as kind of a regular occurrence within the flow of our application. And that's why we're handling this up in this onNext method. This is where you would handle major application errors, as I just said. We're not going to worry about that. And as far as onComplete is concerned, we're not actually going to use that at all. So the last thing I'll talk about is, again, to go back to this disposable thing, what we're saying is when we attach this Flowable to this subscriber here, that's going to create a disposable. I'll talk about that later, but we're going to attach this whole thing, the resulting object of this whole friggin' mess. It's going to get added to our list of disposables, and the only way that that's really going to help us is that if we have like an arbitrary number of these reactive streams or disposables, then we can clear them and just handle them a lot easier. So that's all I really want you to think about with that. So that's our presenter. The next thing we're going to do is write our repository data source implementation, and then that's it. That's all the code we need to write. So hopefully you've made it through this far. If you have, good on you. Stick with me. We're almost done. So it was complaining earlier about this method simply because in the starting point view interface, it had imported the wrong repository list item. So just make sure that your imports are consistent between the two packages, or modules rather. Anyways, let's get started with the repository data source implementation. So this is the last thing we need to write. So we're going to go ahead and right click on the data package again, go to new Java class, and it's going to be called repository data source impl, which stands for implementation. For the interface, we're going to say repository data source interface, of course. Then go ahead and create that. It's going to ask us to implement the methods, so I'm going to click on the red space and hit Alt-Enter, implement methods. There we are. And before we write that method, let's just set up the basics of this class. So we're going to, of course, need an instance of our REST adapter. So we're going to say GitHub REST adapter, and let's create a constructor. So Alt-Insert constructor REST adapter, and again, we're just going to slap an annotation on there for the Dagger2 stuff, inject. So when we need to give us a REST adapter. So that's all we need to do there. And then again, we only have one primary method in this entire class that we need to write, which is going to be this one down here. So again, let's go line by line through what's going on. So first and foremost, we know that whatever kind of happens, whatever our REST adapter returns, which is actually, if you've noticed, not a list view model, it's going to be returning something else. Let me just pull it up. It's actually going to be returning a list of repository data models. So what we're going to basically handle here, I lost my class here. So what we're going to do is whatever happens, regardless of what REST adapter or any other sort of data source, whether we need to talk to several or whatever, you know, maybe we have a local data source as well. Regardless of all that, at the end of the day, we need to somehow produce a flowable of this kind of object. So what we're going to see is how RxJava can help us transform our data over time. And this is, again, it's kind of high level stuff, but it's really cool when you actually see what's going on. So first and foremost, let's get started here. We're going to type return REST adapter.get user repositories, and of course we're going to pass in that user object which came in through the presenter, like so. So first and foremost here we're saying get me user so return a flowable, oh, my typing is terrible today. Return a flowable of type list repository data model. And that doesn't actually have an angle bracket here. So we're saying return a flowable which wraps this kind of object. So that's number one. Then we're going to say .flatmap. Let's just type it out and then I'll explain how it works. Whoa, my IDE is freaking out here. So again, just like the on-error return, we're going to say new function, and we'll explain what function is I'll explain what it is in a moment. So new function, and then again, it's kind of done some of the work for us, but we understand already that what essentially when we say function list repository data model, what we're talking about is this right here. So that's kind of a key point. We're saying when this function is called and this function is going to produce a list of repository data models, we want to publish it as something else. So in the publisher, we're going to type list view model. I'm just going to hit enter so that that's actually on the screen. And what else can I do to kind of clean this up? That, you know what, that's good enough for now. Maybe I'll just kind of hit that. And then what is this publisher going to return? Of course, the list view model. Okay. So what are we actually going to do in here? So as I said before, what we're essentially saying is, okay, we've got this function that's going to be returning this particular, a flowable with this kind of data. And what we essentially need to do, what FlatMap's function is going to do, is we're going to say transform the data from repository data models to, what's the other one? List view models. This is the input. And then this is the output. I'm going to have to do that. Let's see if I can get that to actually output. So this is the output. Okay, great. Let's carry on here. So this method's going to take a little while to write. So I'm going to just get rid of that whole return thing. So first and foremost, we're going to say list repository list item. Sorry, this is a lot of code to write, so I'm trying to make this reasonably quick. Equals new array list. Okay, so first and foremost, we're creating a list of repository list items, and that's what we're going to use to create our list view model, as we'll see in a moment. So what we're going to do next is we're just going to have a quick check to see if our list of data that gets passed in from the REST adapter is null. And what that's going to look like is if repository data models dot size equals 0, then we're going to say throw new IO exception, and for the message we're just going to say empty data set. Just kind of a quick and dirty way of handling that little error. So in this particular scenario, we could have a situation where we send a proper GitHub username through the adapter, but that particular username just doesn't have any repos associated with it. So it would kind of show up as a blank screen, and I'd rather throw kind of a sort of regular error instead. And of course, this is going to pop up in our on-error return operator, which is, again, kind of a handy benefit of RxJava. Anyways, let's carry on here. So what we need to do next is we want to map from the basically our repository data model classes into list view model classes And we're going to do that for the whole collection. So we're going to say for repository data model repo, and then we're going to supply repository data models as our collection. So this is an enhanced for loop in Java, if you've never seen one before. And basically how it works is this is our collection that we want to iterate through, and then this is like a temporary variable for each item in the collection as we iterate through it. I think when I finish the code you'll understand how it works if you're not familiar already. So we're going to say listItems.add, and then we're going to say new repository list item repo.getDescription repo.getCreatedAt. And then for this last one, I actually forgot to create this earlier, so we're just going to open up repository data model really quickly here. And then we're just going to add one extra field here. So what I'm going to say is public string, then we're going to say get avatar URL. We can actually give it a nicer name, avatar URL, just like so. And then what we're going to do is we're just going to say return this.owner.getAvatar URL, like so. And then what we can do is come back here and then say repo.getAvatar URL, and we have created and mapped to a new kind of sort of more view-friendly view model. So for each of those items, we're going to sort of iterate through that list. And the last thing we need to do in this big block of code is we're going to say return flowable.just list view model.success, and then we pass in the list that we just created up here, which is list items. So again, without going into major specifics here, what we're doing with flowable.just is we're say emit what's in the brackets. That's really all we're saying here. So we've satisfied our return type here, and we can call this FlatMap done. And there's only one thing left to do, which is to tell this whole operation to run on the IO thread. Now, I have to admit, I'm kind of an idiot. I actually forgot to pass in the base scheduler interface into this class. And what I'll do is in the finished project over there, I'll make that update and that'll be ready and working to go. But for now, we're going to cheat a little and break my rule and take the entire point out of using the interface, which is to say we're going to say .subscribe on, then we're going to say schedulers, schedulers.io. And of course, why is this bad? Well, now we can't unit test this class, so you are going to eventually want to swap in the base scheduler provider, but I think we're all tired of working with RxJava at this point, so let's just kind of call it a day and say that this line of code here, oh, it's not going to format nicely for me. So what we do here is we essentially say, do this work fetching the data and transforming it on a background thread, like so. So that's basically it. What we're going to do next is, as with all of my projects, we're going to keep working on it until it builds, but that is kind of the end. I'll probably babble a little bit about RxJava as well, but yeah, let's see if we can get this project running. Okay, so I ended up catching about 7-ish different import errors. So like I say, you're really going to want to go through the starting point package. In particular, there was a couple classes in the DI package. List activity was kind of messed up with imports. GitHub application, I think, had a screwed up import. And then one of the scheduler provider classes as well. So just go through the classes. It's only going to take like 2 minutes, and just make sure all the imports are correct. And if you do that, like me, you should have a sort of project that's working now. So what I did after that is I went to build and then make module starting point, and the project did build. And then I deployed that to an emulator, and I'm very happy to say that it does appear to be working so far. I haven't actually tested this yet, but the first thing we're going to do is I'm going to test out my username, which is, of course, _cove on GitHub. And let's see how that works. And boom, we have our data. So yeah, that's basically the end of this tutorial. I'm just going to crack into an outro video, but I have to say, like, that's usually fewer errors than I normally run into when I do these sort of long-form tutorials. Anyways, let's jump into the outro. If you've made it this far and you're an RxJava beginner, congratulations! That wasn't easy. Let's talk a little bit about what we did in the big picture, whether that stuff made a whole bunch of sense or very little sense. So why did I bother with all of this RxJava, and why did I think it was a good idea to try and teach it to you? Essentially, when I looked at this sort of scenario, I said, all right, well, we want some way to easily handle errors, but most importantly, we need some way to get our data from our data layer to our presentation layer, whatever you want to call it, model and view, I don't really care, but the front end and the back end essentially. We needed some kind of pipeline between the two. Now it just so happens that with RxJava we were able to do a couple extra things to the data as it flows through the pipeline. So in one particular example, since we want our two sort of ends of our application to not know how the other two work, which is a good separation of concerns, then we wanted a data type for one end of the sort of the input of the pipeline and a data type for the other end in the output. And RxJava not only did it allow us to communicate between sort of the two ends, but it allowed us via FlatMap to transform them sort of in the middle and throw an error if we like, or just handle different states over time. So sort of in wrapping things up, what we've essentially done is we've created our data sort of represented as a data stream which can sort of change based on different events that occur. Now, I'm not really saying that this is sort of event-based programming, but there are certainly elements of that that are kind of arising in the things I'm talking about here. So anyway, suffice it to say that that is my lesson on using RxJava to wire up to a retrofit REST adapter. I hope you enjoyed that. It was a pretty intense lesson. In the next video, what we're going to do is we're going to look at ways that we can test our retrofit REST adapter and implementation using mock web server. Thank you very much. Do me a favor, hit the like button below if that video is useful to you. It took me a while to make, so thanks a lot, and we'll see you in the next video.